Thank you very much, Doctor. First of all, I would like to know if everybody can hear me well, and maybe, I don't know, like write something in the chat if that's the case. Perfect. Okay, just wanted to be sure about that. And then I thank you very much for Ohio State to organize this webinar and also for my PI for having me here and present the data that we have regarding our project. So, with that in mind, I would like to start with our presentation. So, I would like you to have a brief outline of what are going to be the main things that we're going to be discussing today. So, first of all, it's going to be an overall introduction about who we are, what are we doing, and why we are discussing specifically the topic of organic dairies in the United States. Then we're going to be moving on to the challenges and characteristics of production in these systems. And then we're moving specifically to a clinical mastitis outline. And last of all, we're going to wrap up with some tools that we think and resources that are going to be very valuable for you and your dairies that you could be using for your management decisions. So with that, I would like to start with the introduction in that aspect. So first of all, we would like to give you a brief introduction of because we know that you have like different backgrounds. So we would like to level the floor in terms of what's going to be the things that we're going to be discussing on today. So first of all, I would like to give you a definition of what's going to be one of the main actors that we're going to be discussing today, which is going to be mastitis, which, as many of us we know, it's infection that it's occurring in the udder of not only cows but in mammals overall. And it's a very common, specifically disease that it's happening in dairies overall, not only organic, and it generates a very huge impact for several three areas, which is the treatment cost that it's associated with the disease itself. Then we also have an impact that comes from the losses that we are going to be having in yield and from the losses from the revenue from losing that yield actually. And then there's also a very huge impact that we're going to be having because of that decreased yield and that decrease in overall health from the animal. We're going to be having an increased risk and an increased situation and impact from culling or removing the herd, an animal from the herd, and also from mortality itself, which could be the worst case in that aspect. And this disease is not only going to be related to the impacts on the cow or the herd itself, but it's also going to be impacting the milk quality itself, which is in the end why we're going to be here, because in the end, dairies are going to be run because they are a business, right? So we're interested that our customers are keeping buying our milk and whatnot. So with that in mind, maybe you're starting to wonder. So that's great that we're going to be having this general introduction about what's mastitis. But then if we already discussed that every cow can produce milk and every cow can get mastitis, then the natural question would be why to focus in organic, right? So with that, and I think it's a very nice question to ask, I would like to present you a little bit of the data that it's going to be related on why we're going to be focusing or why it's going to be the specific discussion about organic dairies. So if we are looking to the data that we have regarding US milk production, specifically in 2021, and I'm going to be discussing a little bit why we chose specifically that year, we are speaking that we had around 226 million pounds of milk produced during that same year. But during that same year, if we consider also how much organic milk was produced, it was only 2% of the total US milk production during that year. And then you would say maybe it's a very few proportion of what's going to be produced at the national level. But what's very interesting, it's that if we are taking a look into the total organic sales and what's the organic market, which is specifically what we're going to be tackling, this is consistently the number one product or commodity that it's going to be sold or it's going to be generating revenue by sales in that very same year. And that's going to be consistent from the information that we have from the National Organic Survey organized by the USDA and the National Agricultural Statistics Service. It was the case in 2014. It probably was the case in 2017. And of course, it was the case in 2021. So this is something that it's recurrent and it's important to take in mind that even though it's going to be a very few proportion from the total milk production, it's a very important commodity that we're going to be having specifically for this system. So now that we have this in consideration, we also are going to enter the challenges or what's going to be the counterpart of also having like a very good revenue from the sales of the milk. And we're going to be touching a little bit on that specifically on the production side. But with the good, it also comes the bad, which also means that the organic dairy herds are having absolutely an increased revenue from their sales, but they are also going to be having increased costs, which come from the land that they need to lease in order to run their operations, from the certification costs that they need to be doing, and what it takes to not only certify the whole herd, but certify every single cow that is going to be within their production systems. And then something that it's considered not only once a herd is already producing, but a transition, if we are going to be looking into that. So if we are going to be, and that could be a whole different webinar on what are the requirements of the transition, what's going to be the requirements for certifying a cow as organic, what treatments they are allowed. We could take another whole discussion into that. But this is just to give you a brief floor of what we're going to be discussing regarding of the good and the bad in the challenges that we have in organic dairies. And then also what that shapes management decisions, because that's something that it's very crucial and it's going to be something really important to discuss. Because of course we're going to be having dairy management in both conventional grazing and organic dairies, but there are very specific things that are innate and they are unique for organic dairies that are going to be shaping quite a bit what's going to be happening, how they could tackle different issues regarding the management in those areas. So the first thing that we need to take into account is what's the origin or what's the certification that we're going to be having for the cows. So as I mentioned before, we could be having a whole webinar that is specifically on that topic. But what we need to understand is that specifically for dairy, we could only use animals that are certified organic dairy cows in order to be having a organic certified dairy herd. And those cows are the only ones that can be used to sell organic milk to a co-op or to whatever market we're going to be doing. Also, something that is going to be really important, it's the feed that is going to be given to those animals. So an important consideration is that specifically for organic, which comes from the guidelines from the National Organic Program, which is the one that rules what are the rules of the game for organic production. It's that no mammalian or poultry byproducts can be used to feed organic dairy cows. And most importantly, that they need to have per year at least 120 days grazing, which could equate easily to 1/3 of the year. And from those 120 days of grazing, at least 30% of the dry matter intake, which is how much feed a cow can intake in a day, should come from those grazing, from that grazing that it's going to be done within those 120 days. So that shapes quite a bit what's going to be the panorama and the scenario for this kind of herds. And then lastly, which is also something that is going to be crucial, and it's usually what's more associated with what are the requirements and specifications for organic production, it's that there are very, very strict and clear rules on which type of substances can be used and which ones cannot be used in organic dairies, which the one that is most required to be mentioned is that there is a prohibition in the use of antibiotics and restriction in certain substances that, of course, I'm not a vet. So those are things that you need to consult with a vet, but it's very clear from the rules that they are on the National Organic Program. And of course, that equates that there cannot be also no hormonal treatments, for example, for synchronization in terms of reproduction, for time reproduction and insemination. But something that it's really interesting and that sometimes gets overlooked, it's that actually vaccination it's allowed in certain substances. So that's why we encourage you to reach out to your veterinarian so you can check specifically which are the substances that are allowed or not. But that's a strategy that could be also incorporated into your dairy herds, right? So now that you have a clear panorama and a clear scenario of what organic dairy production looks like in the US, because the rules also vary quite a bit if we go to Canada or we go to Europe, but we're going to be discussing specifically what are going to be the rules of the game in the United States, right? So with that, as a brief introduction of the importance why we're doing this, it's also how we came up with this project, which is called the Solutions for Controlling Mastitis and Improving Milk Quality in Organic Dairy Farms, an integrated approach, which is the grant under which I am currently doing my grad school here at UW-Madison, and which I have a lot of my colleagues in UF and Ohio State and Cornell. So with that in mind, we're a multi-state collaboration, which the diverse universities, as I mentioned, it's Colorado State University, University of Florida, Ohio State, Minnesota, Cornell, and of course, Wisconsin. So with that in mind, that's the overall name of the project. But what are the topics that we're going to be introducing into this specific grant? Well, one of the first objective, which is actually tackled in this very same session, it's the extension objective that we have, which is to develop and deliver integrated mastitis control and milk quality extension programs. We're also interested as a second objective in dry-off methods, which is in evaluating dry-off practices and interventions to improve early lactation milk quality, which is we know that it's a stage that is crucial. We also are aiming to develop as a third objective the mastitis index, which is to quantify the mastitis burden and determine the best opportunities for prevention and control. But this index is specifically going to be tailored for organic mastitis index control. Then we also have a fourth component that is the cow behavior, which is an evaluation of how the behavior is going to be related to mastitis risk using precision technologies in that aspect. And then lastly, which is the topic that I'm going to be more focused on, and it's our main topic here at UW Madison, it's risk factors associated with suboptimal milk quality and mastitis risk, of course. And it's going to be related to identifying those leading risk factors and talking a little bit about them. So that's going to be, now that we have that clear picture, this is an overall layout of what are going to be the goals of today. And first of all, based on that last objective, we would like to present to you a little bit of the insights and preliminary results that we have on key drivers and characteristics of production that organic dairy herds have within different regions. Then, as a second step, we're going to be discussing the factors that are influencing specifically clinical mastitis and its outcomes across different lactations. And then lastly, we're going to present you some tools and resources that we are hoping that you could be potentially looking to incorporate into your data-driven management within your dairies. So with that, I would like to start with the first topic. So we're going to be focusing on production. So a first question we're going to be having is where our data comes from. So that's very logic in the aspect of how we're going to be leading to there. We luckily had a partnership with DRMS, which is Dairy Records Management System. So they are based in Raleigh, North Carolina. And then specifically for this objective that we're going to be discussing, I work with two different data sets, which one is the identification data set, which contain information about breed, RFID, a lot of the things that help us identify particular cows across different herds. And then we also have summarized lactation records that we have within those very same herds and those very same cows. So in the end, what we did was merging different data sets, these two data sets into different subsets of data sets in order to start analyzing and performing these descriptions and these characteristics of the production metrics that I'm going to be presenting a little bit later on, right? But prior to jumping into that, I would like to show you what's going to be the one of the strengths that we have within our study in comparison to some previous work that it has been really valuable and has set the stage for understanding the dynamics of organic production into the US. And it's that we have a very rich data set in terms of information and in terms of regions. Because if we start looking at where those herds are located within the US coming from our data, first of all, we're going to be looking into the four different regions that we have within the US. And luckily, we have the four regions represented within this specific objective. And we're going to be looking at first at the Midwest, where we're going to be having states like Iowa, Illinois, Indiana, Michigan, Minnesota, Missouri, Ohio, and Wisconsin. Then we're going to be moving on to the Northeast, and we're going to be having states like Massachusetts, Maine, New York, Pennsylvania, and Vermont. And then we're going to be moving south, and we're going to be having states like Kentucky, Louisiana, Mississippi, North Carolina, Oklahoma, Tennessee, Texas, and West Virginia. And lastly, we have the West region as defined by the regions according to the United States Department of Agriculture. And we're going to be having California, Colorado, New Mexico, Oregon, and Washington represented in our data set. And then we're diving deeper into what's the representation and what's the distribution that we have within those very same regions of our data. We're looking that it's overall pretty well balanced in terms of the amount of records that we're going to be having within each one of those regions. For the Midwest, we're going to be having, from our total records, we're going to be having 20% from the Midwest. From the Northeast, we're going to be having 21% from the total. Then from the South, we're going to be having around 28%. And from the West, we're going to be having 32 records. But what's really interesting It's that we also have the percentage of the proportion of hertz that are distributed, unique hertz that we have within one of those regions. And we can see very clearly that the Northeast, it's the one that has the vast majority of the amount of hertz that we're going to be having within our data set. And the one that has the least amount of hertz, it's the West, which is going to be a little bit more logical once we dive into the production analysis, and that's going to help us build and describe the characteristics and the current panorama that's going to be occurring within each region, right? So with that, we would like to jump into what was the main objective and what we would really like to do within this specific objective, which was evaluating the effect of different parameters, but that they are going to be described with different production and performance metrics. So we wanted to evaluate first what was the effect of region and the number of Kelvins that a hertz had per year, which it was a proxy for hertz size. And then we would also wanted to evaluate what was the effect of region, Kelvin season, and breadth into the following metrics that we're going to be discussing, which is not restricted to the rest of the analysis that we're going to be doing, but for the sake of time, I'm only going to be presenting one of those results. But I just wanted to show you what's going to be looking into that. So we're going to be looking at different models and different statistical methods that are going to help us predict and characterize what's going to be occurring with those specific regions and those specific covariates, which are the things that are going to be shaping the different performance metrics that we chose, which are a standardized 305 day mature equivalent metrics, which is milk, fat, and protein. And we chose the standardized 305 day mature equivalent for a simple reason, which the calculation of this metric itself, it's considering different breeds, different regions, and also the hertz mates that are occurring with those very same hertz in order to give an estimate of, for example, if we're talking about first parity cow or a second parity cow, and that cow eventually leaves the herd, this metric, what allows us to represent or model, it's what would be her production if she got or she stayed in that herd until she reached maturity. So it's those metrics are going to help us to be giving a very fair comparison across different herds and across different parities for these specific characteristics that we're going to be looking into here. And for the sake of time, I'm only going to be presenting the results for milk production. But what I would really like to highlight is that I'm going to be showing two different plots and in two different formats. But what's not going to change, it's the colors and the characteristics of each one of the plots. So first of all, the one that has like the crisscross pattern and that it's blue for those people that can distinguish color pretty well, it's going to be the Midwest. And then it's always going to be followed by a bar plot that it's going to be the Northeast, which is the one that it's a single solid color. Then the one that has the little spots and that it's red, it's going to be the South. And then the one that it's diagonal lines, it's going to be the West and that it's orange colored, right? And then the results that we're going to be seeing over here are going to be, as I mentioned you, presented as bar charts in order to do an easier comparison as to see what's the distribution of the milk production that we're going to be seeing here, and it's going to be with the predicted means. So very important to understand that it's not the actual raw data that we have, but an estimate considering the different characteristics and effects that we're going to be considering, which are region, Kelvin season breadth, and region and number of Kelvins. And they are going to be also including the standard error. And then in order to give it a weight that it's from the differences in a statistical analysis, each bar plot is going to be having different letters. And if, for example, two bars have a different letter, that indicates that they are different, considering this specific test, that it's the Tukey pairwise comparison test. So with that, I'm going to walk you through the different bar plots and the results that we had for our analysis. So this looks like a lot, but I'm going to walk you really slow through this so I can help you understand what's going on with this bar. So first, in the y-axis, which is the one that has the 305 mature equivalent milk in pounds, it's what was the predicted average per region and number of Kelvins, which is the x-axis. So we have four different categories. We have hertz that average less than 50 Kelvins per year. We have hertz that they had between 50 and 100 Kelvins per year. And then we have hertz that will have between 101 and 500 Kelvins per year. And then we have herds that have more than 500 calvings per year. And then something that you can probably distinguish quite away, it's that there is no green bar or there is no solid bar in the 500 calvings per year. And that's a very insightful thing because when we dove into the data, what we notice it's that the Northeast does not have hertz that they have more than 500 calvings. So that helps us also to set the stage and understand that specifically this region does not count with large hertz, which could be the same case, for example, when we are looking at the different distribution of the West, which is the striped line, when we're looking at less than 50 calvings, the fact that the standard error bar, which is the black line that it's like very wide, it let us understand that the variation is quite high, and it's because there are maybe not a lot of hertz that they're going to be under 50 calvings per year for that specific region. So that's just a little bit to set the stage. And now we're going to be diving a little bit deeper into what are the differences between those different regions and the amount of calvings that they had per year, right? So first of all, in order to understand this category, I'm going to be doing a very clear comparison as to what's going to be differences statistically speaking. So when we look at the Midwest, that the Midwest, it's the one that has like the crisscross pattern. It has the letter B on top, and then if we go to the south, that it's the one that has the dots, we see that it has the letter A, and we can very clearly see that the Midwest it's averaging between 13,000 pounds of milk per cow when they are in the category that it's less than 50 calvings per year, which is equates at around a herd size of less than 50 cows. And then if we see the south, it's that they have a lower average, which is ranging between 8,000 and something and 11,000 pounds per milk. So these letters, what they represent, it's that these two regions, they differ from each other, right? But then, for example, if we look at the Northeast, we see that the letters are different, which of course let us understand that they differ from the Midwest and the South. But then, if we compare it to the West, the Northeast, and the West, they do not differ from each other, and that has to do with the large variation that we're observing in the less than 50 calvings category for the West, right? Moving onward, when we're doing the comparison between the 50 and 100 calvings per year, we can see very clearly that the Northeast and the Midwest, they are pretty similar, but they differ from the previous category in the terms of the Midwest. And then we're also seeing that there are differences between the Midwest with the South and with the South, but not with the West again. Moving onward to the category of 101 to 500 calvings, we can see that the Midwest and the West and the Northeast story, they do not, and the West, they actually do not differ from each other. And we can see also that the South is starting to pick up. So we're starting to see how the South and the Midwest, they are increasing their production as they are progressing within each category. And then lastly, we have the large calvings category, and we can clearly observe that there is a clear winner in here in the predictions of what's going to be the average of cows in that region. And we can see that there's clear differences between the Midwest and the West, for example, but the South and the West do not differ from each other. So in conclusion, what I would like to give you from these bars, it's that the Northeast and the West, they have a very constant milk yield, specifically when we're looking, into the categories that they are between the 50 and 500 calvings per year. And then there is an increase, as I mentioned you, between the Midwest and the South regarding milk yield as we progress with the different herd sizes. And then the largest differences, of course, as we can see very clearly in this bar, it's occurring between the category of less than 50 calvings and more than 500 calvings. But there are pretty much no differences when we're comparing the 50 to 500 calvings. So moving onward, this is another comparison that we made, which if you remember one of the slides that I showed you, it's to measure the effect of the breed, the calving season, and the region in order to see what's going to be the distribution or what's going to be the characteristics of milk yield in those different regions. So this one, what I would like to share with you, it's that the comparison, it's only for a given breed and a given season if the regions differ from each other, right? So the interpretation is a little bit more straightforward compared to the other bar chart. So first of all, we're going to be starting with the Holstein. And as we can see very clearly over here, we can see that the Midwest and the Northeast, which are the blue and the green bar in here, they do not differ from each other in terms of production, which they are averaging around 21,000 pounds of milk per cow for the Holsteins. And we can see very clearly that they are having a very quite a difference between the South and the West in terms of production. As we can see that the South is averaging between 16,000 and 17,000 pounds of milk for the Holsteins. And then the West, it's averaging around 18,000 to 20,000 pounds of milk per cow. But then we're also seeing an effect of seasonality in here, where actually the lowest uh, milk yield it's going to be occurring in the winter, and then maybe we're going to be discussing a little bit into that in the insight section of this objective. Then moving onward to the crossbred, we're going to be seeing a very different pattern because actually we can see very clearly that in the Holsteins, there was a very clear effect of seasonality. So we could see an increase and then we could see a decrease. But in this one, actually, if we are comparing the Midwest and the Northeast, the crossbred cows that they are in here, they are actually not fluctuating quite a bit in comparison to the previous panel that we had. And we can see pretty much the same behavior where also the South is going to be the lowest yield that we're going to be achieving for the crossbreds, and it followed prior to the Midwest and the Northeast, it's going to be the West in that aspect. And then lastly, for the jerseys, we can see a very different pattern in which actually we could see that the Northeast and the Midwest, they were pretty similar for Holsteins and crossbred, but in here, the jerseys from the Midwest, they differ quite from the Northeast jerseys and actually from the South and the West jerseys. So this is something interesting to look into it because actually their milk yields, they are pretty close across seasons, but they do differ quite a bit in terms of region. And the only case where the Northeast and the West, they do not differ from each other, it's in the fall. So as a conclusion from this section, it's that overall we can see that the Northeast and the Midwest, they have the greatest milk yields for Holstein. And then we can observe pretty clearly that overall, the lowest milk yield that we're going to be having for 3 or 5 day mature equivalent milk, it's going to be occurring in the South, with exception of the Jersey cows, that it's going to be occurring in the Midwest, as I showed you quite a little bit ago. And then specifically for the crossbred cattle, as I mentioned you, there's a lower variation in the milk yield across seasons in comparison to the Holsteins and the Jerseys. And calving in winter showed an overall lower milk yield. So in terms of take-home messages of the production analysis on what could be potential explanations as to why this is occurring, it has been quite documented in the literature, specifically looking into studies that they have been doing, actually combining and comparing conventional with organic herds or grazing herds with organic herds. It's something that has been coming up very consistently. It's that larger herds, they are actually consistently having a higher average of milk production that has to do with, or could be explained partially, because they are more likely in comparison to smaller herds to seek out professional support from nutritionists, veterinarians, consultants, and be enrolled in the HIA programs, which is the Dairy Herd Improvement Associations, which are the ones that do the monthly test, milk tests, and the somatic cell count tests. Specifically for the breeds, we can see also how these differ quite a bit from the conventional, where usually the Holstein is going to be the breed that it's king. But in organic, it's very interesting because they are actually favoring the multi-bred or crosses for adaptability and performance, specifically because of the component that we were discussing earlier, which has to do with the grazing component that we're going to be doing, which actually it's something that usually, at least, it's something that there's still some work to be done in terms for the Holstein. For the regions, we can see overall that there's a lower milk yield in the South, which has been reported quite a bit in the literature, and that's usually associated to the climate stress that could be happening due to the heat and the humidity that it's innate to that region. And specifically for the seasons, it has been documented also in several reviews that there is an influence on the quantity and the quality of forages. And specifically because we're dealing with a system that it's based quite a bit in terms of grazing, and it depends on it. So the impact that the milk yield and the components are going to be having due to that disposition of the forages is going to be substantial in that sense. And then taking that into mind, it ties pretty well with actually a concept that has been developed actually like 30 years ago, which is how the organic definition of health was constructed, and this was extracted from a book by Benson and Circles, Organic Dairy Farming, which is what would be the concept or what would be the priorities that actually organic health is based for animals in that term. So we can see that at the base, we see the soil life and balance, but we also, in second place, we see that the pastures and grazing management comes as something very, very important. Water management also is something really important, breeding, housing, equipment. But on top of it, as we discussed a little bit previously, it's the medication component of what's going to be included into that. So this is something that let us set the stage for the next topic, that it's going to be the mastitis analysis. But considering what's going to be the description and what are going to be the priorities of organic dairy production, right? Specifically talking about the US in that aspect. So with that, we're going to be jumping into the second analysis, which is going to be about clinical mastitis. So with that, also, we're going to be doing a little bit of the presentation of the data, which was also provided by Dairy Records Management Systems. And overall, we use the same data, the lactation records, the identification records, with the only difference and the component that in this one, we are also considering the health data set that was provided by the RMS, but I would like to highlight and make very clear that from the health data set, we only received mastitis information. We did not have access to any other disease that was reported by the herds. So we were only able to extract the information that was related to clinical mastitis. And then with that, I'm also going to be showing the distribution of the records, which is very important to understand as to why we ended up with the characteristics and the structure of the design of the analysis that we're going to be doing in comparison to the previous analysis. So overall, we were really excited because in the beginning, we analyzed that we had quite a variety in terms of the number of herds and the number of regions that we had available at the health dataset, which is the clinical mastitis dataset. But then when we started to look into the distribution of the records and what are the characteristics that we're going to be having, we noticed that 93% of the records that we're going to be having in that specific data set came from only 4 herds, which were located in Colorado and Texas. And also, I would like to give a word of precaution in that aspect. So what this means that we have quite a huge distribution of records for this specific 4 herds. It does not mean by any means that the other herds or the other regions that we have within those same herds, they do not detect clinical mastitis. But what changes quite a bit, it's the method where they are actually recording clinical mastitis. Because actually, as part of the National Organic Program, one of the requirements is to keep written records and available records. So what we could be taking from this, it's that potentially the other herds, we were not able to access that level and detail of observation because maybe they did not have it online. Maybe we're speaking about smaller herds that they are keeping Excel files or they are taking the records written. And unfortunately, because we're dealing with DHIA data, we were not able to access that information. So in terms to give a fair comparison, we only restricted our analysis to these 4 herds that were located in 2 different regions of the US, but they were located in 2 different states. So now considering the richness in the data set that we had and what were the characteristics of this, we aim to do 3 objectives for this analysis that we're actually currently working on very closely here in UW-Madison for this specific output. And first of all, it's the lactational incidence risk, which I'm going to be giving a definition in a little bit. And for this specific analysis, we used around 150,000 records, which is quite considerable. And then specifically for the next two objectives, we did parity specific data sets, and I'm going to be explaining a little bit into that in detail as we progress specifically to that section. But we used overall, combining all the data sets from different parities, we used around 60,000 lactation records, which that means that they are cow lactation records. So, first of all, jumping into specifically the lactational incidence risk analysis. So, I would like to give a definition of what's the lactational incidence risk analysis and why is it important. So, the lactational incidence risk analysis, it's a metric. It's a parameter that we can use and define as the probability of experiencing a certain event, which from an epidemiology or a health aspect could be any disease. But for the purposes of our analysis, we're only going to be discussing clinical mastitis, which I forgot to mention that actually in the first slide. There are two states of mastitis. We have the subclinical state and we have the clinical state. And the differences between the two, it's that in the subclinical, the cow and the milk do not present any differences they do not present any visual signs that there's any disease. And with the clinical, that depends specifically from a diagnostic, from a veterinarian, from the people at the technicians that they are at the milking parlor. So that comes from visible signs that the cow is experiencing disease either in the milk or either present in the cow. And that lactational incidence risk, it's the probability of experiencing a certain event throughout her whole lactation, right? And then for our analysis specifically, we did it and we calculated it specifically per parity group, and we did it for different stages of diagnosis. So we did it for first, second, and third case of clinical mastitis. So what was the incidence risk, or what was the probability that a cow from a given parity would develop clinical mastitis at any point throughout her lactation, just given her parity, which is a proxy for age, right? So jumping specifically for the results of this objective, we can see very clearly that the incidence risk it's going to be increasing by parity, and this is what's the lactational incidence risk that it's going to be having for the first case of clinical mastitis. So to put it shortly, if we have 100 cows and we're looking at 101 first parity cows, we could be looking that just by being first parity cows, 17 of them, they are at a risk to develop clinical mastitis. And then if we move forward to 100 cows of second parity, we're looking at 21% or 21 cows having the risk of developing that outcome. And then so on and so forth. We move up until 4 or more lactations, which is the highest risk, which is at 32%, which is almost 1 in every 3 cows, which is quite a bit. And based on the test that we did, all the incidence risk based on the whole populations that we had specifically for each one of those diagnoses, they differed from one each other. So there was no overlap in that aspect. But with clinical mastitis and with any disease in particular, it's also important not only to detect or to understand what's the probability or what's the risk that that specific disease is going to occur, but sometimes, depending on which disease we're discussing, it's the time at when that specific disease is occurring. It's also very important. Which, for example, if we're taking a disease like, for example, dystocia, it's not, which is the calving difficulty that we're going to be having when a cow is giving birth. We are not going to be expecting that dystocia is going to be diagnosed later in lactation. It's an event that it's only going to be occurring at the day the cow is going to be calving. And with that, it carries other diseases, but specifically for mastitis, it's going to be really interesting to see the next slide, because it's going to give us a very clear picture of what's happening in terms of the dynamics of infection, right? So now we know that first parity cows, they were at a lower risk of developing clinical mastitis. But what's really interesting is that if we start comparing it with the rest of the parities, we can see that the distribution as to when those cows are diagnosed, it's very earlier in lactation in comparison to older cows. So what that means, and the median, it's another elegant way to say that we're sitting at where 50% of the records are. below and above that. So what this means, it's that for first parity cows, which is the upper left panel, that 50% of the diagnosis of clinical mastitis occurred within the first month of lactation for first parity cows, right? And then the 50% remaining, it's going to be occurring up to 308 days, right? From that median. And then when we move forward to second parity, third parity, and fourth parity, we see that those diagnoses and the medians, they are occurring later in earlier lactation, around 80 to 100 days in milk. And that's really interesting because it's allowing us to understand that there's quite a bit of variation as to when the first parity cows are going to be diagnosed in comparison to older cows. And maybe at the end of this specific section, I'm going to be able to give you an insight as to why this could be occurring. But then moving forward, we have the lactational incidence risk for a cow to develop a second case of clinical mastitis. So in the first one, we were discussing what was the probability that a cow developed one case of mastitis throughout her lactation. This is the result. These are the results for the cows being diagnosed 2 times with clinical mastitis. And we can see that it's a decreased risk, but still quite considerable. If we're looking, for example, as first parity cows, they are a lesser likelihood to develop clinical mastitis. Then we see that the highest risk it's going to be occurring also in 4 or more parity cows with 11%. So what that lets us understand, it's that, for example, 1 in every 10 cows, it's going to be at a higher risk of developing clinical mastitis for 2 times throughout her lactation. And then moving forward, for the lactational incidence risk to the third case, we can see that it's also a decrease in comparison to the second and first, but still, we can see very clearly that the dynamics and the distributions are the same, which the first parity is going to be at the lowest risk to develop a third case of mastitis, and older cows are going to be having a higher risk of developing mastitis. And what's also really something important, it's that for second and third cases of clinical mastitis, we did not see that variation in terms of one group overlapping with the other. What we saw actually for the time to diagnosis and the distribution of the records and where those diagnoses were occurring, we looked at it at the second case of mastitis. They occurred around mid lactation. So we're talking about 150, 166 days, the median time to diagnosis, which is when we would be expecting those second cases to occur for a cow. And then for the third case of mastitis, it actually occurs even later, moving not only to the late gestation, to the late lactation, sorry, but also a little bit for the later side of the mid lactation. But this is really interesting because actually, when we compare it to the literature that has been reported in conventional and other types of herds, this actually differs quite a bit because in other studies they have reported in New York, for example, in Holstein, the same breed, they have reported that actually the multiparos for second and third cases of mastitis, they were diagnosed earlier in comparison to first parity cows. So this is something interesting that maybe it's innate to the system that we're going to be doing, but it could also be an explanation of how much we have progressed in terms of genetic selection for mastitis. This was a study that was done around 20 years ago, approximately. But the most important thing, and what would be the take-home message regarding the first objective that we did for this analysis of mastitis, it's that overall risk to develop mastitis, it's going to increase with parity or with age. And that has been quite a few times documented, and it's something that is going to be important, and it could be applied as well for organic dairies. So now that we understand that risk is going to differ by parity, it made us wonder if risk is going to differ by parity, then maybe the factors or the things that are going to influence that risk, they are going to be different by parity as well, right? So that's why we move on to the second and third analysis that we did, which was the factor and survival analysis, which they had the aim of understanding which specific factors from the cow, not the management, from the cow, they are going to drive cows to have an expected outcome that for us it was very important in terms of organic dairies, because as we know, and as we mentioned, organic cows, they cannot be treated with antibiotics, they cannot use antimicrobials, and they rely very heavily in preventive management. So for the specific analysis in here, we wanted to focus not on the sick population, we wanted to focus on the healthy population, right? So what is the probability that a cow remains free of clinical mastitis in early lactation, which is the most critical period, and a period where around 75% of the health disorders of a cow occur. So what's the probability that that cow and the factors that are associated with that cow remaining free of clinical mastitis disease, right? So for that, we used previous and current lactation information from the cow to understand which are the characteristics that are associated with the success that a cow remains free of disease in that aspect. And moving forward, specifically and for the sake of time, to what were the overall factors that were associated with this outcome, which is that cows remain free of disease by 100 days in milk. Four emerged within the different parities, and then I'm going to be talking a little bit on the distribution of which are the specific factors that affect or influence that outcome specifically for each parity. But first, it was 305-day mature equivalent energy corrected milk. So opposed to the production analysis, what we did in here was to consider and correct for 3.5 fat and 3.2 protein to make a fair comparison. And then we divided cows in groups, given their calving contemporary groups, if they were a low, an average, or a high producer, right? To make a fair comparison and see if any of those groups, they were at a higher susceptibility or they were at a higher opportunity to remain free of clinical mastitis. And then when we're discussing also previous lactation, mastitis history is crucial in order to determine, we hypothesized that it was crucial to determine the success that a cow remained free or not of clinical mastitis. And then dystocia was also associated, and we're going to be touching a little bit on that. And lastly, the only factor that came out as significant from the current lactation, which is the analysis for second, third, or fourth parity that we're going to be doing for a given cow, it was calf sex or number of calves, which number of calves means if it was twins or it was only a female or a male calf. So for second parity, what came out as very significant was milk yield, which is a second parity in her previous lactation, which was as a first parity, if she was a low, average, or high producer. If as a first parity, she had 0, 1, or 2 or more cases of clinical mastitis as a primiparous cow, and if she had or not dystocia during the previous lactation as well as primiparous cow, and then if she had a male, female, or twins during her current lactation as second parity cow, right? Then for third parity, we only had relevance or association with previous lactation factors, which were milk yield and number of clinical mastitis cases. So these are the factors that were when these third parity cows were second parity cows. And then for fourth parity, the factors that were associated with the probability that cows remain free of clinical mastitis was also milk yield, clinical mastitis, and from the current lactation, if they had a female, a male, or twins. And for the sake of time, we're only going to be focusing on 2 of the factors that appeared across the 3 parities, which was milk yield and clinical mastitis cases. So for second parity, we did a survival, third and fourth parity, we did a survival analysis, which it's analysis, a descriptive analysis that allow us to see different populations if they differ from each other in terms as to how many remain or are associated with a certain outcome. So in here, what we are going to be seeing in the y-axis, it's the probability that the population remains free of clinical mastitis if they are average, low, or high producers based on their milk yield from the previous lactation. So it is very clear in here that actually when cows in their first parity were low yielders in comparison to their herd mates, they were at a lower probability to be free of clinical mastitis by 100 days in milk in the next lactation, which is the second parity. And then average and high producers, they do not differ from one each other, but they do differ with low producers in that aspect. And then we can see when we move forward to the parity three that the high and average, they also do not differ from each other, but also that the high producers, they do not differ from the low producers in terms as to when they are diagnosed with clinical mastitis or that the probability that they remain free of clinical mastitis at any time point within that early lactation period. But the average and low producers, they do differ from one each other. As we can see, for example, here, uh, average producer for the third parity, the around 87% remains free of clinical mastitis by 100 days in milk. And then for low producers, it's around 85%. And then, of course, the probability decreases with age, which is the susceptibility that is going to be accumulated with time. And we can see that the behavior from the second parity is translated to the fourth parity as well. And then one of the most interesting and dramatic effects that we observed during our analysis was the carryover effects that we saw from cows diagnosed from the previous lactation, carrying that risk to the next lactation. So as we can see very clearly in these plots, we can see that cows in the green line, which is the top one for all the parities, if they didn't have any clinical mastitis cases during the previous lactation, the probability that they remain free of clinical mastitis in the next lactation, it's pretty high. It doesn't fall more than 90% for all the parities. But when we start having at least one case, the risk drops dramatically, and the probability drops dramatically that they do not remain free of clinical mastitis. It falls at least from 7 to 10 points in comparison to one of the parities in that aspect. And then if they had more than two or more cases, the probability also drops dramatically in the aspect that they are not going to be remaining free of clinical mastitis. So what this allows us to see, it's that not only the risk is going to be differing by parity, but also the factors that drive that risk for each parity are going to differ from one another. And this has been documented quite a bit also in the literature. When there's a previous lactation clinical mastitis history, the magnitude and the impact that those cases from the previous lactation cause in the next one, it's going to be increased as well. And then actually, when we're looking into the literature and what has been reported before, the logical thing would be to think that the high producers are at a higher risk to develop mastitis. But in our case, and in our data, the low producers were at a higher risk to develop mastitis, and the average and high producers were not different from one another. So what that has been reported in at least one other previous study that was done in Florida, it's that could be partially explained because of the suboptimal component of other health that was developed from the cow. And then something that we would like to take away from this for this specific objective, it's that not only the factors differ, but when the cows are diagnosed and specifically those factors, they also differ from each other. And then with that, I will also like to wrap up just very quickly with some tools that could be used and that we would like to provide to you. And I will be more than willing afterwards, the end of the seminar, to discuss them deeply, if that works for you. But I would just like to give it a quick glance for those people that need to leave for at 3 p.m. or 4 p.m. In the East. So first of all, I would like to give you an invitation to actually a program that was developed here at UW-Madison by Carolina Pinzon, which is one of the extension specialists here at UW-Madison. We know that milk quality and mastitis control, it's very important. And as you can see in the plots that we have presented and information, the effects are real. So we would like to invite you to this online program that it's self-paced, and it's something that it's going to allow you to have a lot of information and a lot of knowledge on what are the current strategies that are going to be working for mastitis control and milk quality, on top of being certified as a trainer for the milk quality from the Other World program. Then there's also a very good website from Michigan State University, which is called Top Milk, which is developed by Dr. Pamela Rueg, which was a former professor here at UW-Madison as well. But what I would like to highlight in here is that there's also a very interesting tool, which is called the Antibiotic Usage Benchmarks tool, which is a tool that is developed and is currently tailored specifically for being safe for the dairies, in order to for you as a herd manager, as an owner, to quantify what's your current usage that you're having of antimicrobials and antibiotics in your herd, and with that, see what potential changes you could be doing for your management in that aspect. And then, last but not least, I would like to thank also my PI for the opportunity uh, of being in his lab and getting familiarized with a lot of resources and tools that could be of use in that aspect. And the one that I would really like to highlight, uh, specifically from the topics that we discussed, it's a tool that is called Improved Milk Bulk Tank Somatic Cell Count, which is a tool that allows you to run different scenarios based on how much you get paid for your milk, and the somatic cell count records that you get from the test day, if you're enrolled in a DHIA program, or if you're having also, it could be adapted if you're having daily milk weights from a robot or from your partner. And there are very useful tools and guidelines that will help you walk through those different tools if you enter to that website. And just for the sake of time, I'm not going to go through an example. That was my idea, but apologies for taking the time in that aspect. But with that, I'm open to any questions or comments that you would like to make. But thank you very much for your time.